Good day, everyone. So, we were going to tackle about increasing and decreasing a function. So, we can identify intervals over which the function is changing in specific ways. We say that a function is increasing on an interval if the function follows increase as the input values increase within that interval. Similarly, a function is decreasing on an interval if the function values decrease as the input values increase over that interval. So, we see the sorry, we see the picture here, the paragraph here. So let me zoom in. Okay, the upper. Okay, so this is the graph of increasing and decreasing. So next is the derivative of a function may be used to determine whether the function is increasing or decreasing on any intervals in its domain. If f of x is greater than 0 at each point in an interval 1, then the function is said to be increasing on 1. F of x, f of, of f, f of x is less than 0 at each point in an interval 1, then the function is said to be decreasing on 1 because the derivative is 0 or does not exist. Only at critical points of the function it must be positive or negative at all other points where the function exists. So, in determining interval, which a function is increasing or decreasing, you first find domain values where all critical points will occur. Then, test all intervals in the domain of the function to the left and to the right of these values of determine if the derivative of positive or negative. If f of x is greater than 0, then f is increasing on the interval, and f of x is less than 0, then f is decreasing on the interval. So, example, for f of x is equal to x4 minus 8x2. Determine all intervals where f is increasing or decreasing. The domain of f of x is all real numbers, and its critical points occur at x is equal to -2, 0, and 2. Testing all intervals to the left and right of these values for f of x is equal to 4x3 minus 16x. You find that f of x is less than 0 on the quantity of negative infinity and -2, and f of x the greater than 0 on the quantity of -2 and 0. F of x the less than 0 on the quantity of 0 and 2. F of x the greater than 0 on the quantity of 2 plus infinity. F increasing on the quantity of -2 and 0, and the quantity of 2 plus infinity, and decreasing on the quantity of negative infinity and -2, and the quantity of 0 and 2. So we have another example here. Example for f of x is equal to sine x plus cos x on 0 and 2 pi. Okay. Determine all intervals which f is increasing or decreasing. The domain of f of x is restricted to the closed interval 0 and 2 pi, and its critical points occur at pi over 4 and 5 pi slash 4, testing all intervals to the left and right of these values for f of x is equal to cos x minus sine x. You find that f of x is greater than 0 on 0 and pi over 4. F of x less than 0 on the quantity of pi over 4 and 5 pi over 4. And f of x of greater than 0 on the quantity of 5 pi over 4 and 2 pi. F is increasing on 0 and 5 slash 4, the quantity of 5 pi slash 4 2 pi, and decreasing on the quantity of pi slash 4 and 5 pi slash 4. So, thank you for watching and listening. God bless.